Now this is a converse. If two straight line segments AB and CD intersect at P so that PA into PB is equal to PC into PD, which is the secant property of a circle, then the 4 points A, B, C and D are concyclic. So obviously, to prove such kind of theorems, we will go by contradiction method. For example, let us say this is the circle and we are talking about these two chords, okay, which intersect at this point P. Let us say this is A and this point is not B. Let us take it as some E, and let us say B is somewhere outside, and C, and this is D. So it is given that PA into PB is equal to PC into PD. But we have assumed that the circle passes through A, D and C but not through B, but it passes through some other point E, right? This is our assumption. So we will prove this assumption wrong. Hence we will say that A, B, C and D lie on the same circle. How do we say that? If I have assumed that E lies on this circle, so I can say by secant property of the circle that PA into PE should be equal to PC into PD. But we know that this is a relation that is given to us, right? So comparing these two, what can I say about PB and PE? That PB is equal to PE. So it is not possible for us to have any point E which is apart from this point B, right? Which satisfies, which lies on this circle where PA into PB is equal to PC into PD. Hence, by contradiction, we have proved that E and B cannot be two different points. E and B can only be coincident points, right? Because PB is equal to PE, it can happen only if B coincides with E, right? Okay. Now there is one more thing that I would like you to pay attention to. If let us say there is a circle, right? And this is an external point P, and I draw this secant and I draw this tangent to this same circle, right? Let it be T, this is point of contact, right? Let this be A and let this be B. Now the relation between PT and PA and PB is that PT squared is equal to PA into PB. PA into PB is equal to square of this length of tangent. How do we prove that? Let us say, let us join B with T, A with T, okay, and let this be the center of this circle, right? Now let us say I focus on these two triangles PTA, PTA and PPBT. All right, focus on these two triangles. This angle here is an angle between chord AT and this tangent, right? So this angle is going to be equal to this angle here. These are angles in alternate segments. Angles in alternate segment, hence these are equal. If somebody doesn't know it, then he can watch this video of angle in alternate segment, which is in the same playlist. So if this angle is alpha, this angle is going to be alpha, and this angle P is common to both these triangles, this one and this bigger one PBT. Okay, so what can I say about these two triangles? That these two triangles are equiangular or similar, right? Because this angle P is equal to angle P, and what is angle T or angle PTA? It is equal to angle PBT. So these two triangles are equiangular. So the ratio of their corresponding sides is equal. That is PT, this PT divided by PB is equal to PA divided by PT. right? Now if I cross multiply, PT squared is nothing but PA into PB. So this is another important relation that you need to memorize or you need to take care of. So what have we learned so far? That if there are two chords that intersect inside the circle, let us say this is AB, this is CD, and these intersect at this point P, or if we have got two chords AB and CD intersecting outside the circle at P, AB, and this is CD. Or we studied about third case where let us say there is this point P and this intersects the circle, this line intersects the circle at A and B, and there is another line which is tangent to this circle. So what were the results? That PA into PB is equal to PC into PD in these two cases, and in this third case we studied that PA into PB, that is the product of this segment and this segment, is equal to square of the length of this tangent here, right? This is an important article and you should take care of this. All right.